Good morning all. Welcome to physics class. Today I am going to speak on the topic thermodynamics. In that we will discuss on entropy, concept of entropy, change in entropy in reversible and irreversible process. So before that, going to the change of entropy in reversible and irreversible process, let us define entropy. Entropy is a thermodynamic variable similar to that other thermodynamic variables like temperature, volume, pressure, etc. It is also a thermodynamic variable. So if we consider any substance in solid, liquid and gaseous state, we know that in solid state molecules or atoms are tightly bound, and in case of liquid, molecules are free to move, and if you consider the gaseous state, so this increases, and hence we can say that disorderness or randomness increases as we move from solid to liquid and liquid to gaseous. So thus entropy can be defined as the measure of disorderness or randomness of the molecular arrangements in a system. So next let us see what will be the change of entropy in case of reversible process. For that, let us consider a reversible Carnot cycle, so represented by ABCDA as shown in the figure. So here we are going to consider the reversible Carnot cycle, so that is A, B, C, D, A. So now let Q1 be the quantity of heat absorbed by the working substance along A to B during isothermal expansion at temperature T1. So from PV diagram, the curve AB represents isothermal expansion at temperature T1. So now when heat is absorbed, Q1 is positive, and hence the change in the entropy will also be positive. So therefore the gain in entropy of a working substance from A to B, from the curve A to B, is given by Q1 divided by T1. So next, from the curve B to C, it represents the adiabatic expansion where there is no change in entropy because the process is adiabatic. So we know from the definition of entropy, change in entropy is given by ds equals dq divided by t. So in adiabatic process, heat neither enters or leaves the system, so therefore dq equals 0. Hence the change in entropy ds will be equal to 0 in case of adiabatic process. So then during the isothermal compression, which is represented by the curve C to D, then the working substance, here the working substance rejects some amount of heat. So let Q2 be the amount of heat rejected to the sink, which is maintained at the temperature T2. As a result, the change in entropy decreases. Hence, the loss in entropy of the working substance is given by Q2 divided by T2. Again, from the curve D to A, which represents adiabatic compression, so there is no change in entropy because the process is adiabatic process. So thus the total or net gain in the entropy of the working substance in a complete cycle is given by Q1 divided by T1 minus Q2 divided by T2. But for a complete reversible process, we know that Q1 by T1 must be equal to Q2 divided by T2, or Q1 by T1 minus Q2 by T2 will be equal to 0. So this implies that the total change in entropy of the working substance in a complete cycle of reversible process is equal to 0. Or in other words, we can say integration over complete cycle ds will be equal to Q1 divided by T1 minus Q2 divided by T2 will be equal to sigma Q by T equals 0. That is, change in entropy is 0 in case of reversible process. So next let us consider the change of entropy in irreversible process. So for example, if you consider an irreversible process like radiation, so where heat is lost by a body which is maintained at higher temperature, say T1, and gained by a body which is maintained at a lower temperature, say T2. So we know that T1 greater than T2. So now let Q be the amount of heat given out by the body at temperature T1, so and the heat gained by a body at temperature T2 be Q. By considering the hot and cold bodies as one system, so we can write loss in entropy of the hot body is given by Q by T1 and gain in entropy of the cold body is given by Q by T2. So therefore, the total increase in entropy of the system is given by Q by T2 minus Q divided by T1. But we know that T1 greater than T2, hence Q by T2 minus Q by T1 is positive. So thus the entropy of the system is always increases in all irreversible process. Thank you.